Hello, my name is Hassan. In this video, I'm going to talk about derivatives of functions. Before I start, I would like to say that if you have any questions about the material that I present, please write it on the comment line. Um, let's talk about the derivative of a function. First of all, derivative of a function is another function. And let's see what that means. Let's write down a function. Let's plot a function. This is y-axis. This is x-axis. Let's assume we put like an arbitrary function here, fx. And the derivative of this function at any given point x0 is the slope of the tangent line to this curve. So you just draw a tangent to the curve at a specific point, and the slope of that line, slope of the tangent line, gives you the derivative of the function. Derivative of the function at x is equal to x0. Okay, so the derivative which we show as f prime of x is another function, is a new function, and it's defined as it admits a value of x0 and it takes it and it converts it to the f of f prime x0, which is the slope of the tangent. So for example, if this x0 is 1, if the slope is 2, the value of the derivative f prime at x is equal to 1 is going to be equal to 2. So it takes the value and it sends it to the slope of the tangent. Let's try to find the derivative of a given function. So how are we going to find it? This was the definition. In order to find it, you draw some arbitrary line which passes through two of the points of the function, like this. Okay, let's assume this line intersects the function at x0 and x1, 2 points, and let's assume that x1, the second point, is delta x apart from x0. So this is x0 plus delta x, which means that this distance is delta x. We know that this is not the tangent line, so the slope of this line is not the slope of the tangent line, but we can make this very close to the tangent by shifting this x1 to closer and closer value to x0. So if we move this x1 from here to here, okay, we are going to obtain a new line which is going to pass which is going to intersect 2 points, but it's going to be, the slope is going to be closer to the slope of the tangent because it's approaching the tangent. The tangent, the special property of the tangent is it touches the curve at only 1 point. Okay, so, but it's really difficult to tell the slope. So let's just try to find the slope of the line which is not the tangent but very close to the tangent. Okay, so the slope of this line is going to be equal to the change in the y value, which is the value of f at x is equal to x1 minus the value of f at x is equal to x0 divided by the change in the x value, which is delta x, or just x1 minus x0. Okay, so we can insert, instead of x1, we can insert x0 plus delta x. So it becomes f of x0 plus x delta x minus f of x0 divided by x0 plus delta x minus x0. The x0's cancel. We have just delta x as the difference of x. So this is the slope of the line. But we need to make this look like the slope of the tangent line. How are we going to do that? It's simple, because we can make this delta x smaller. If it approaches 0, then this line approaches the tangent line. So if delta x goes to 0, line approaches the tangent line. This arbitrary line that I drew approaches the tangent line. So the slope of the line is going to approach the slope of the tangent line. Okay, so the derivative of f at x is equal to x0 is going to be the limit delta x goes to 0 of this expression, f of x0 plus delta x minus f of x0 divided by delta x. So this is the definition of the derivative, and it's basically nothing but the slope of the tangent line to this curve. Let me give you an example. Let's try to find out the slope of the tangent line for the function f x is equal to x0. Sorry, f x is equal to x squared. This is x, this is y-axis. Let's try to find the slope at any given point x0. Okay. Now, again, we try to estimate this value. So it's the f prime of x0 is going to be limit delta x goes to 0. We just estimate this expression. F of x0 plus delta x is, if you insert x0 plus delta x in the definition of this function, which is x squared, you get x0 plus delta x squared minus f of x0 is x0 squared for this example divided by delta x. We need to find the limit of this expression. Let's try to simplify it, because in this form the numerator and the denominator approaches 0, so it's going to give you 0 divided by 0 indefinite. Not indefinite, but yeah, you cannot calculate it like that. But what you need to do is you need to simplify this expression. The numerator becomes x0 plus 2 delta x x0 plus delta x squared minus x squared x0 squared divided by delta x. So x0 squared, so there is x0 squared here, sorry, forgot x0 squared. So this is x0 squared plus 2x delta x, x0 plus delta x squared minus x0 squared. X0 squares cancel, and this expression you can take into the parentheses of delta x, so it's going to give you the delta x 2x0 plus delta x divided by delta x. Now, although this is still 0 divided by 0, so we need to calculate as delta x approaches 0. So although this is 0 divided by 0, you can simplify this expression by canceling the delta x terms. Here you assume that delta x is very close to 0 but not 0. So you're allowed to cancel them because you can assume it as non-zero. Then this expression becomes limit delta x goes to 0, 2x0 plus delta x, and when delta x goes to 0, this expression approaches 2x0. So the derivative of x squared, the function x squared, is a new function which is 2x0. So it takes the value of x0 and sends it to 2x0. This is the definition of the derivative of this function x squared. Okay. So it's going to take any value x and it's going to multiply it with 2 and it's going to give you the slope. So for example, at x is equal to 1, the slope is going to be 2. The slope of this line is going to be 2 for this function x squared. At x is equal to, for example, 2, the value of the function is going to be 4, but the slope is going to be 2 times 2, which is 4. Yeah. And if you let's try to make a table. You can solve as an exercise. You can find the derivatives of different functions. Okay. Let me write a table for the powers of x. The powers of x to the 0, which is equal to 1, x to 1, which is x to 2, x to the power 3, and so on. Say x to the power n in general. We found that the derivative of the function x squared is 2x. And if you do the same mathematics, you're going to find that the derivative of the function x is going to be 1, and the derivative of the function 1 is going to be 0. Derivative of x cubed is going to be 3x squared, and for any function, for any power of x to n, the derivative of fx is going to be n times x to n minus 1 in general. So you can solve the rest as an exercise, but we have formulated this for x squared. Let's see whether these look reasonable for these two cases. If you have a function fx is equal to 1, it's going to be a constant function like this. Okay, this is 1. This is fx is equal to 1. No matter what you input, you're going to get 1 always. And the slope of the tangent to this curve is always 0 because no matter which point you choose, it's going to give you the horizontal line as the tangent, so the slope is going to be 0. So it's the 0 function. The derivative of 1 is going to be the 0 function. If you plot fx is equal to x, it's going to be this linear function. And no matter which point you choose, the slope of the tangent is always 1 because it's 45 degrees with the horizontal. So as you see, the derivative of the function x is 1, which is consistent with this picture. But for any arbitrary x to the power n, you can figure out that the right expression for the derivative is n times x to n minus 1. Okay, thank you very much. Hope to see you in next videos.